Hey everybody, this is Larry or Snorlax. This is me going over Q4. Whoops. Q4. Pretend that's 4. Of the weekly contest 265. Check if an original string exists given two uncoded strings. Happy Halloween. And if you're watching in the future and be very confused, it's Halloween. Hit the like button, hit the subscribe button, join me in Discord, especially if you like talking about the contest forms and so forth. This one was I thought this one was a very good problem in concept. Very, very annoying to implement. I implemented my way. There are actually a lot of different ways to implement this, and a lot of people actually solved it in a much shorter code. But I'm going to explain my code and some emphasis here, right? So for me, the tricky part, and you can watch me solve it live as a virtual contest next. And the thing that I kind of noticed is that just looking at the constraints, right? And not only this, so the first one is that n1 or n2 is up to 40, and then the second part is that there could only be 3 consecutive digits, and that means that it allows us to do some brute force in a way, and yeah. And the first way that I thought about it, let's skip this, is it is going to be dynamic programming. The way that I thought about it was that it is kind of similar to LCS, LCS being longest common subsequence, something like that. But basically the idea is that we try to match one character at a time, right? Or something like that, or some characters at a time. So here let's just say we have some match and we have some index one, index I1 and I2 for S1 and S2, and then we can, in that case, we go, okay, we just look at if, this is S2 and then right? And then dot. And then the second thing that you can do is thinking, okay, well, you can, this is if this is an alphabet, but if this numeric number, then you have to, parse it. And if you watch me solve it live, that's basically what I did, is that I wrote out a lot of code. And that's the one thing that I would say is that I go, okay, well, actually, with a number, you can go over, right? So now we expand this to some leftover 1 and leftover 2, which is the number that we parsed for leftover 1 and leftover 2. Here I thought at the time, and I didn't really analyze this correctly, to be honest, that, well, I1 can go from 0 to 40, so this is 40. I2 can also go from 0 to 40. Here we go, okay, I don't know what this is yet, but I had some incorrect interpretation, which actually later led me to 2 wrong answers. But I go, okay, maybe this is 40, and also left 2 is you go to 40. So this is a little bit expensive, right? Because this is about 2.56 million, but it also turns out that this can be more than 40, because this can be going up to 999, and this is 999, right? And now if you do that, then that's going to be 1,000 times 1,000 times 40 times 40, which is, I don't know, there's no commas here, but like 1.6 billion or something, which is too slow. But that was my idea at the time. So while I implemented this out, I thought, okay, wait, actually, we don't need both of these because they can be combined into one number, right? So this can be now from -999 to 999, which represents certain things. So this is only so leftover. So this is about 2,000 or something like that, right? So now that means that this 40 times 40 times 2,000 is 3 million, and it should be fast enough. So that's basically the idea that I had, and I'm gonna go over the code. So the idea on these dynamic programming problems or memorization problems is just be as brute force as possible. That's pretty much it, to be frank. Be as brute force as possible, and for that I mean going through every possible case. This is not going to be very code efficient or even efficient in code implementation time, but it assures you that you will get the right answer eventually, right? That's the way that I would recommend it. And if you look at the video of me solving this live, that's basically what I was doing here. yeah, so let's go over the code without further ado. And again, there are going to be other code that other people did that are much shorter, and I recommend you looking at those code as well to learn the things. But for me, this is just me putting in as many test cases as I can, to be honest. So yeah. So here I go, okay, leftover is the number of characters that I1 owes I2. I even wrote out an additional note that and this is me during the contest, the positive means that we can freely use I2 characters, right? Yeah. Keep in mind that, yeah, and I1 is just the index on S1, I2 is the index on S2. I'm not going to go over dynamic programming basics on this problem because there's enough to go over. I do dynamic program basic videos in other videos, so definitely check those out, but let me know. But yeah, but here, basically, I'm just going over all the base cases. If we reach the end of both strings and leftover is equal to 0, then we have true, otherwise it's false. If they go over, then this is false. Otherwise, I go, okay. If this is the case, then S2 prefix needs to use the leftover. Also, if we need to use S2, and it is at the end, then we return false. That's why we have here. Here, we just basically go for every possible case. And implementation-wise, it's a little bit yucky. But if the first character of this prefix or of this suffix is it's an alphabet, then we use one of the leftover, and this is basically the new state, and we return that. Otherwise, if this is a number, then we try the 3 possible cases, right? Which is that it is a 1-digit number, so we try it. If it's good, then we're good. We try it if it's a 2-digit number. If it's good, we return and it's good. If it's a 3-digit number, we try it, and then if it's good, it's good. That's basically all there is, right? And every time we add to the leftover as part of the new state, and we also shift, for example, here we shift 1 digit because we use 1 digit. Here we shift 2 digits because we use 2 digits. And here we use 3 digits, so we just use 3 digits, right? This is the same but opposite direction. This is just for S1, so I'm not going to go over it, but it's the same idea. And then here, this is if leftover is equal to 0. I actually wrote out all these test cases. I don't even think it's necessary. You can actually reduce this to one of the previous cases if you like, but that's what I did. So during the virtual contest, I go, okay, if leftover is equal to 0, then if they're both alphabet, then we do this thing. Otherwise, if one of the number is numeric, then we try parsing it as 1 number, as 2 number, as 3 number, or 3 digits. We tried that here, and we also do the same for S2 if that's the numeric one. And of course, one of these has to be numeric, so one of these will execute. But yeah, and then we start off at the index 0, 0, and with 0 leftovers, meaning that no one owes any in terms of numbers. And the reason that we can do it is because this is basically saying that, okay, if we use 1 digit, then this is 1 digit of leftover and so forth. So I think the concept is not that bad, and that is way brute force. We just try every possible thing. But as you can see, the way that I did it is 101 lines of code. You can definitely write in a shorter way, but it's a mess, and it's just a lot of implementation. So just to analyze this, of course, I1 can go from 0 to 40. I2 can go from 0 to 4. And leftover can go from negative 1,000 maybe to positive 1,000. And the reason is because as soon as this becomes non-zero, you consume it from the other side, and because of this 3 digit, it's going to be 999. So you can these are the maximum range, maybe even negative 999 or something, right? Which is but yeah. But as you can see, for each of these scenarios, we only do a set amount of cases. So this is going to be O of 1 per case. So what is this, right? So this is actually O of N1 times O of N2 times, let's just say U for now for the domain. This is the number of possible inputs. U for the domain of this thing, which is a function of the number of digits, of consecutive digits. But yeah, this is the number of possible inputs. And well, one is you go to time and time spent per input. So in total, it is going to be this thing as the total time. And also, it's going to be total space because it is also all one space per input. That's pretty much all I have for this one. Let me know what you think. Ask me questions, so you can ask it, so I can answer it, and then maybe try to figure out how to, But yeah, but overall, it's gonna be brute force. Yeah, you can kind of see. I'm gonna show you the first part, and now the second part of the code, and then the last part. Like I said, I don't think this is good learning code per se, but I want to focus on two things. One is, especially for contest, just write out the solution. Even if you think it's going to TLE or time limited, just write it out. Because that's what I did, and I actually I wouldn't say optimized it, but I noticed the pattern a little bit after I did it. So it is part of the discovery as well. And two is you only get penalized if you get accepted at very end. So keep on doing it. And if you don't get, if you don't get it correct at the very end, then it doesn't matter anyway, right? So even if you think it's going to time out, make the system tell you that you're too slow, right? Don't assume it's going to time out. That's all I would say for this one. And also be careful, because I made some error where I thought so basically why I got two wrong answers. For some reason I thought this can only go up to -40. I think I confused myself for some reason, because I thought that this would be bound by here. So that's why I got two wrong answers, because I also have a typo and I forgot to fix it in the other place. Yeah, but overall this is an annoying to implement problem, but not so bad in terms of understanding. I hope that my video kind of helped you do the understanding part. Basically, I think the only thing is just, this is standard thing, and this is just for parsing the number. And we brute force up to three possible number interpretation. So yeah. Anyway, that's all I have for this one. You can watch me sub it live next, and remember, support Snorlax. Snorlax. Anyway, see you later. Okay, easier than I thought. Okay, let's see. Check if original string exists given two encoded string. It's only 78 people, so I'm cheating a little bit. Okay, let's not look at that. Let's look at my current leaderboard. Okay, so no one has finished this yet. Actually, maybe I should have done this contest live. But okay. Well, I mean, I wasn't in town anyway, or I wasn't near my apartment. Okay, let's actually read the problem. Like, focus. Almost there. Original string is of lowercase English letters can be code. Okay, split in a sequence. Split some number. Okay, choose. Replace each with its length. Concat to see. Okay. Choose a second and third. Okay. That's just weird. Okay, I mean, I guess that's an encoding, but that's like a lossy encoding, so it's a little bit awkward. But okay, let's kind of see what. Given two encoded strings, return true if there's existent or order that can be encoded as both. Okay. Okay, so it's an original string that can be this. So you have to get the original string, not the later string. Leetcode was earlier, so then you. This is so weird. So, okay. First of all, I guess we just check the length to make it even possible. Otherwise, it's just not possible. But then you have stuff like this, which is clearly not possible. Can I do some sort? Okay, as the length is 40. Maybe I should have looked at this first. If I have to guess, I would guess it's maybe dynamic programming at this point. I am a little bit more verbose because I am in a virtual contest mode versus actual contest mode, but yeah, I mean, we could scan that out. Let's see. Oh, but the problem is that the length may be a little bit weird because it can have 12 and not just one. And how many times does it? Oh, okay. So actually, I misread this a little bit. I thought that you can keep on doing these, so you can keep on encoding. But it seems like you can actually encode only once. So maybe that's an easier from. Still think it's going to be dynamic programming where, like similar to LCS type things. Number of consecutive digits does not exceed 3. So I think that's the case where you, yeah, try that. Yeah, but it's still a little yucky to, I don't know, maybe there is some TLE factor. Let's see. Is it, what is that? 40 times, I don't know. Okay, let's play around with it. Okay. Let's play around this problem. I think it's going to be dynamic programming, but I don't really know, to be honest. What are the states? I mean, the easy state should be I and j, but I don't know if that's sufficient. But let's start with these. Yeah. If I is equal, let's go n1 is equal to length of s1, n2 is equal to length of s2. I just go, is this cleaner? I don't even know anymore. If I1 is equal to n1 and n2 is equal, I2 is equal to n2, then we turn true. Otherwise, if I1 is equal to n1 or IT is 2 is equal to 2, then we turn false. Okay, these are the base case. They have to be, okay, so the lowercase letter, the original has to be, like the original cannot have numbers, right? Okay, yeah, okay, just want to make sure. So then, okay, how do I want to do it? Okay, if is alpha and s2, I think I'm just going to be really, like, I have a lot of time. Where am I? I don't know how much time I have left because I'm on virtual mode. Okay, so I have an hour left, so I'm going to be try to be as exhaustive as possible. There may be some patterns that we can make to make this shorter to code, but for contests, I'm just going to yeah, do that. So if they're both alpha and they're equal, then let's actually put this inside in the loop. If they're both alpha, then there are really only two cases. If this is true, then we return goal of I1 plus 1, I2 plus 1. Else, if they're not equal, then we return false. Okay. And then now there's the other case of, okay, so this is alpha, and as of 2 is numeric. So we can at most take 2 digits, and only if it's, yeah, okay. I mean, that'll be easy check anyway. So let's see. Yeah, okay. Okay, let's actually rewrite this a little bit. So they're both not both alpha, then if S1 is numeric. Let's see. Okay, actually, if they're both numeric, I think that's another case, but then otherwise, let's just return something for now. Fill this in. Otherwise, then that means that it's a mix. Then I think this one's easier to handle for now, so let's do it. If S1 is numeric, then we just brute force of up to 1, 2, or 3 digits. So yeah, okay. Yeah, okay. X is equal to int of S1 I1. Okay. return go of I1 plus 1 because we moved that one, and then I2 plus this is not right, but okay, if this is true, then we return true. And then the other thing is looking at 2 digits. If I1 plus 1 is less than N1 and S1 I1 plus if this is a numeric, then X is equal to int of S1 I1 plus 1. I hope this is right. I always mess up this. Plus 2 I2 plus X return true. I have to do some bounds checking here. So yeah, so if I1 is greater than N1 or I2 is greater than N2, then we return false. But actually we shouldn't do this here because function overhead is kind of expensive. So we should actually do this here. If I2 plus X is less than N2 and this, then return true. Okay. So this is obviously not complete, but I am gonna write it this way and then test it just to see if I run into any obvious like crazy error. Okay, so not bad, not great, but not bad. Let's just return true to see what happens. Does that change the answer a little bit? Okay, so we're doing stuff. Okay. Yeah, and then now we just have to do one more. I mean, there is a loop here, so I should have done it this way. So yeah, for t is in range from 0 to 0, 1, 2, right? I always get really bad about this, but yeah. So we have x I1 plus t. Hopefully that's right. Yeah, plus x and 2 and t plus 1, then we good, right? Does this crash? Yep. Okay, what am I crashing on? Oh, I have to check that they're numeric as well. If S1 plus t is numeric, if this is not, then we actually well, we just return false then, right? Because that means that this has failed the other stuff. So yeah. Do I need this? I guess not. Even though the for loop initiation could be a little bit expensive. Yeah. Okay, let's return true here just so we return something. But I'm still getting this. Am I doing this one? I'm always. I'm always off by 1 here, so it would not surprise me if I'm off by 1 here. Let's see. I think this is plus 1 then, maybe. Okay, so that looks good. Let's see. Am I right, actually? Well, we only do it on I1, so 1. Ideally, it would be... Oh, it only does this... Wait, am I doing it right? Let's see. Why did it go 112 here? But oh, because here it fails earlier on the A times C, and this one we haven't handled as case yet to go deep. Okay, I think we're maybe okay for now. Though actually we never need 3 digits because the other number never has 2 digits, so we can actually submit. I remember thinking about it, but I forgot about it. Okay, so then we try again, which is oh, this is now wrong. Whoops. I think when I took out that for loop or that if statement, this is wrong, but let's just keep this in here because otherwise this is a little bit awkward. And also that should default this to false. 2 is a number. This is just copy and paste, honestly, essentially. Hope I don't make any silly mistakes. I might be off by 1 here, actually. So x is... There's no 0, okay. If x is 1, this increments it by it matches by 1 digit. Okay, maybe that's okay. I don't know that I'm not off by 1, to be honest. I'm really bad at it lately. Okay, so here we're mostly good except for this filter in part, I think. Maybe. Let's see. Oh. How did I not return true? Wow, I just like kind of waiting for half the thing, but okay, let's see. Okay. Huh, how did I do that? How did I miss an if statement? If it plus t is less than n2, this is greater than equal to. 1 plus t. Just checking on the time. About an hour left. How did anyone finish yet? No. That's actually surprising. Okay, so this at least runs without any issue. Is it the right answer? Probably not, because we didn't do this part. Okay, so what happens with the numeric? Then this is the part that I might have to figure out a little bit. We might have additional states actually to compensate. And the number can be at most 40. So that's 40 to the 4th. Is that too slow? Let me see. I mean, that's gonna be 2.56 states. So I really have to be careful. So I cannot be sloppy on the states, because if I'm sloppy on the states, that's gonna get too big. I don't think it can be over 40 anyway. Okay, let's give it a try. Basically, you have left 1, right 1. Oops, left 2. These are just how many things are left. But this makes the states way more complicated now. We have to think about it a little bit more. But basically, these are just the leftover wildcards. Essentially, we have some wildcard things, and we're trying to figure out how to handle them one by one. Maybe I failed. Maybe I ran too much code to add this in last minute. I mean, I still think we have an hour. I think I could fix this, but it's still going to be very annoying to go for all the test cases, or just all the, not test cases, but edge cases. But I think the idea is right. Because this isn't quite 40 to the 4th, because there are only a subset of these that are possible. But it's still going to be messy. Okay, I mean, it is what it is. Let's give it a try. But this is just brute force, to be honest. Yeah, a T1 and 0 and 1, right? Yeah, okay. How do I want to do it? I mean, this is just like I think I know how to do it. It's just messy to type in, because I think now it is way clear. It's just a lot of edge cases and like enumerating them, right? But we have an hour, we can do it, and possibly, not gonna lie, we might discover some through like wrong answers. But I think like we just have to go through, like, this is just hard labor now at this point. There's no more insight for me, unless it gets time limited. Then I might have to do something smarter. I'm pausing right now because I'm just like thinking about how much work this has to be, and it's really annoying. Is there an easier way? I guess continue. I mean, I don't think this makes sense for continue, but I think that should be okay. Whatever. it's easier to do this than to prove anything, but this is going to be painful actually, I think, because I think I have to deal with way more states later. Here x is oops. It's just there's so many potential ways to get to just get it wrong, right? So I think one thing that I could have done, actually this is a little bit dumb the way that I do it now that I see it, because you just shift and times 10, right? Do I want to do it that way, or is it too late? I don't think it affects performance that much. It's not free, but we'll play around with it later. Let's just do the dumb thing first, and then we'll do the optimizations later. I wasn't really thinking about it that much, to be honest. Oh, I see. So the actually now I recognized part of this optimization. One thing that I would say is that you can't have leftover on both the left on S1 and S2. So actually you can reduce this to just leftover and then direction or something, or not direction, but which string or something like that. Yeah, that should be okay. Or maybe leftover can be the delta, so we can use the negative signs for that reason. So okay, I have to. I mean, conceptually, we're okay, but we have to think about how to deal with it. Okay. Let's see. So I1 plus remove T1 string, I2 plus T2 string, and then leftover is leftover plus x minus y. Let me just add some notes. Leftover is the number of characters I1 O's I2. Actually, that mix this up. No, it should be okay. Okay. So, okay, what is positive? Positive means, just because I keep on mixing myself, means we can freely use I2 characters. Something like that. Okay. Return true, and then at the very end we return false, which I guess we have here. But then now we have to deal with the leftovers. Okay. I think conceptually we're at a good place. There's just a lot of annoying things left. Okay. Okay, let's just run it just to see if there are any errors. Let me procrastinate a little bit. Okay. Oh yeah, that's right. I have to update all the goal course. Okay. I can't even do -1. Okay, let's do leftover. This is going to bite me in the butt, isn't it? I might as well do it. Okay, so this one should be right. Okay. Okay, let's determine a little bit first. Okay, so if leftover is equal to 0, we can do all these things. That's not I don't want to do that way. Okay, let's see. Okay, let's just put it on back burner for now. We have some code. It's pretty-ish. So if leftover is 0, what does that mean? Oh, less than 0. Less than 0, then we want to use some letters from man, my leftover I think I'm using the wrong sign, to be honest, in terms of notation. But okay, if this is less than 0, then we can, okay, if, okay, that means that S1 or S2 prefix needs to use leftover. How much time am I left? Okay, we still have an hour. I think we should be okay. Like, I'm not doing it quickly, obviously, but we should be able to solve this. Because now this is at most 40 times 40 times 80, which is much better than 40 to the 4. What is that anyway? oops. Yeah, 128,000. I'm not worried, even with some for loops. So I think I'm okay. Okay. So if S2 of I2 is alpha, then we just return go of I1, I2 plus 1 left over plus 1. This feels a little weird, but okay. If S2, I2 is numeric, then what happens? Then we just parse, yeah, okay, for T is, the way that, I guess for, do I need this? Let's just write it out, okay. So X is equal to int of S2, I2, okay. If go of I1, and well, I have to fix the base states as well. So we go here and left over is equal to 0, then okay, actually I'm jumping a little bit all over the place, I'm not gonna lie, and if you see it, you're right, and I'm not really doing it well. Okay, so okay, I guess that's true. Yeah, maybe that's fine. I want to add another one though, which is that, okay, because I think we can get too lazy on the leftovers if we're not careful enough. So I want to do something like, okay, S2 needs to use the leftovers, but if absolute of leftover, oh, you can't do it that way because you can actually consume it without. Okay, fine, that's fine then, because I was thinking about just checking whether you can go to the end or whatever, or like go out of bounds, but actually I guess because this could be numeric, that's not really possible. And also there are only 2 possibilities, so that's this is okay. Okay, so X and then I2 plus 1, because we used 1 leftover, so leftover plus X, then we return true. Okay, and then now we do if I2 plus 1 is less than N2 and S2 of I2 plus 1 is numeric, then okay, then X is equal to X times 10 plus int of, I don't know if this is much faster, to be honest, but it is, you know, what I said I wanted to do. Let's see, I1, I2 plus 2 left over plus X, return true. Hopefully this is right. I don't know if this is right, but I think this breaking down cases makes more sense. So left over greater than 0, S1 prefix needs to use over. Okay, if S2, oops, what am I doing? Copy and pasting in my mind, I think. Okay, if this is alpha, then we just consume 1 letter. So I1 plus 1, I2 left over minus 1. Okay, and then X. But I think one thing, if you're watching this, to note, maybe it's useful, I don't know if it is that note that like I wrote a lot of these code, and even though I might not end up using it, it is an exploration of how I play around with the problem. Even though maybe there are more efficient ways of doing it, to be honest, but it gave me ideas that I might not have if I just sat around and try to outthink it a little bit. And the other thing I would also say is that it's okay to submissions are free unless you get it correct, right? So if you have to, feel free to YOLO submit random stuff and see if they work, right? Because at worst you just have a huge penalty, but if you don't feel like you could have gotten it otherwise, then yeah, okay. And then the rest assumes that leftover is 0 anyway, so maybe I actually do end up using this, even though it is way code inefficient, but that's fine. Okay, so if they're both numeric, then we brute force this thing. Do I need to do it this way? I don't think I need to do it this way, because this is I think we can actually break it down a little bit actually. Actually, I don't think we need. I mean, maybe this works, maybe it doesn't work. But actually, these states are unnecessary because we can actually just think about it in terms of S1. So this is, and then it'll just generate the leftover would be taken care of in the future by one of these. So yeah, so if S1 is alpha, then we just but we have to do a if someone like this somewhere, I think. Okay, maybe I'm wrong on that one actually. Okay, if they're both alpha, then we have to do some comparison. Oops. I think maybe this one is true. Okay, if S1 is numeric though, if this is numeric, then we can actually just do this thing, I think. Let me rewrite it then. Then we can go if I1 plus 1, we use 1, and then now we have leftover minus x anyway for whatever this number is, and then we turn true, and then we do it again. I should okay, right now I'm going to copy and paste. I don't recommend it, but you know, we'll see. So then now we don't have this nested for loop yuckiness. And then now if S2 is this is yeah, and it doesn't matter if they're both numeric because then it gets overlapped. It will take I think so, could be wrong, maybe I'm wrong, but yeah, but if S1 is alpha and this is numeric, then we just do this thing, and then just gets consumed by the is alpha type thing one at a time, and it gets memorized, so it's fine. I think so, I could be wrong though. Okay, so then now if the should be good actually. This should be good because one of these has to be true, right? Yeah, one of these has to be true though. I'll just leave it like this. Let's see, let's run the code real quick. Hopefully no one-time error and I was wrong. Oh yeah, is this the only place? Hopefully this is the only place. Okay, well, I mean, this is wrong, but so I have true, false, but I do not return this. Okay, oh, actually, this is pretty good. But choose, this is going up and down. I need two monitors. Okay, true. So the second one is true as well, which I have false. Okay, that's not good, obviously, but it'll be okay. How much time I have left? Okay, so we have 50 minutes. We're doing good time. I say that all the time though, and I end up being wrong a lot. So don't take me for granted. Don't take my words for granted. Or don't. I don't know. I'm really optimistic. You can't solve these problems without being optimistic though. So that's my story, and I'm sticking to it. But okay. Okay. So this one is wrong. This one should be true, and I'm returning false. Why am I returning false? Where am I returning false? This should never be reached. So let's. Oh no, that's not true. This should be reached if it gets out of these if statements. I think I'm missing one here because this one has returned false, which is true. Yeah, okay, that's good. But then now we have to do assert false. See if it gets there for some reason. Okay, so that's good. We knew that this shouldn't happen, so okay. But then now what is it going on? What's going on? What's going on? Let's double check just typos in general. We consume 2 characters. I guess that's right. Yeah. Do I have my signs right? This is a mess. This is a mess. Anyone solved? Oh, okay. 4 or 5 people solved it. So okay. Wow. So this is a very hard problem. So it's not just me, because you know, this far in, I would actually expect more people to solve it for a normal problem, normal-ish problem. Okay, what am I doing? I would also say here that if I'm doing it like in a real life thing, I would have a debugger to go through this instead. But you know, this is what this is. Okay, so 0, 2, 4, 4. Okay, so this is gonna be false. 3 and 1, 0, 1, 2, 3, and then 1, -3. Maybe I have some. So this one should return true, but it obviously is not. Otherwise, we would be done. Why is this? What? So this is saying that maybe I didn't account for this. That this numeric. Oh, I see. Because now this is no longer true. Though if either of these is greater than, then it's definitely false. But otherwise, because one of them could be okay. There we go. Where's my print statement? Okay, here. Let's count it out. Oh no. What am I doing? I mean, that should be okay. That should be okay. The bounds should be okay. Why am I getting our bounds error? Leftover -1. What? Which one is it? Because it works for that one. So let's see which problem is. Okay, so that's good. Because then I don't have to go that far to find the Y's. The Y's. Tell me why. And now we can bring back the print statement. So we're just spending quite a bit of time debugging. Okay, so 0 is a 1, and then we assume that this is 1, and then here. Did I mix up the thing? This should be not the state that's after this. Am I wrong? Did I do the wrong sign somewhere? Okay, let's see. So 1, 1, we consume this 1. Oh no, this should be good. No, I'm wrong. So then 2, 2, this is 0. That's true. 3, 4. Oh, I see. Because then now this is if this is because I see, because I2 can be N2. But this is what is it? Line 47. That's weird. But then leftover should not be 0, right? If leftover is 0, 10 and 3. Oh, no, maybe I assumed incorrectly. So 10 and 3 is good, and then 11 and 4. So it probably matched this N or something, maybe? Oh, no, let's see. 5. Yeah, match this N and then goes to the end of the line, and then now it looks at the next one, and then this is N. Okay. What is there to say? If leftover is okay. So I have to do a little bit more checking. Okay. If I2 is equal to N2. Okay, I have to check. Okay, here if the leftover is 0, then if I2 is equal to N2, here we check. Then we return false because that means that we ran out of characters to match. Okay, that looks. I think this is true, right? Let's see. I have to keep true, true, false, true, false. Oh no. Oh no. Wow. I got this one right? Yeah, okay. Is this still right? Pay to win, pay to win. If only I have something local. Okay, so that's 2. Let's see. This is false, okay. Is it going 84? Because 84 would be ridiculous. Maybe that's why. The numbers can go out of bounds because I'm going too much. Let's think about this. Line 33. Okay. Well, clearly, okay. If I1 is equal to n, then or n1, we return false. But that also messes up my state, so I don't know if I can handle. I don't know if there's a bad case that might mix me up, to be honest. Because it gets cached one at a time, and then there's no, it should be okay, maybe. Okay, true, false, true, false. Yeah, I mean, I think there may be a really weird big case with a lot of numbers. We're gonna YOLO a little bit. Am I ready to YOLO? Am I missing some obvious stuff? Let's see. I actually don't know the end. I think they're all true at the end. Okay. Well, they went pretty fast anyway. All right, let's YOLO. Okay. So I did have a wrong answer. That's good. A little bit sad. Was hopeful, but still. Okay. Let's see. Oh, I messed up. One thing I did do is that for some reason, because I got fixed on the 40 number, I thought that the number cannot be more than 2 digits, but it can be 3 digits, and instead it could be, yeah, okay. That was dumb on my part. So that is actually a silly mistake, but that's okay. That's easy to fix. It hurts because I thought I proved it not necessary, but I'm wrong. Okay. And then now we have to do it for this one. This is such. Okay. Okay, let's see if this works. So I expected true. Okay, so now this is true. Hopefully this is just a silliness. Oh no! I was really hoping that was sufficient. So I expected false, but this is true. Huh. I don't expect that, to be honest. Did I mess up? I really hastily did this one though, so maybe I mixed up here. Maybe this should have been inside a loop. Oh, this isn't. Oh man, that is a silly mistake actually. I think I'm washing a little bit too much at home, to be honest. Okay, so this is false, but this is also false now. So I messed up something here. Oh, wait. Oh, I don't do the this is what happens with copy and paste. I missed it in the bottom part. So that was just going to be wrong anyway, but okay. I mean, I was so careful for so long, and then I just gave it away doing silly things. Okay. I really should have took an extra minute on that one. Maybe I'll take an extra minute now. Let's see. True, false. Okay. Now let's give it a submit. Okay. I mean, that was just dumb. Like the wrong answers. I mean, I had it, but I had the silly wrong answers. I mean, I just and I did it twice. So one wrong answer would have been okay, but the second one made me a little bit sad. But yeah. Oh, wow. How do you? Well, I don't know what happened in Q3, but that 12 minutes is ridiculous. But that wasn't that bad. Like I would have been. I mean, the 10 minutes of penalty, so we'll see how that goes. But in theory, I'm like top 25 or something like that, so that may be good. Yeah. I mean, this wasn't that bad. It's just enumerating all the cases, and I messed up because I got stuck with 40. So I just assumed, and I even had the right code in the first try with the for loop. But for some reason, I just convinced myself very quickly without really thinking about it that it can be done in 2 digits, because it can only go up to 40. But then I forgot of the offset and stuff like that. Kind of convinced myself the wrong thing. And then I forgot to fix the bottom part. I just kind of rushed it because I was like, oh, it fixes it. And it was one of those cases where I had 2 bugs, so the 2 bugs cancel each other out to be right. And this is what happens with true false problems in general as well. Okay. I mean, that's fine. I mean, I think I did okay here, top 50 or whatever, with penalty, and also this doesn't count the China server, so like it's gonna be a little bit off, but thanks everybody for watching. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like this cute Snorlax. Yeah. Stay good, stay healthy, to good mental health. If you like these problems, just join me on Discord. Anyway, I'll see you later. Stay and bye bye.